Let's go and do another one.
A wave pulse propagates along a wire in the positive x direction at 20 meters per second. What will the pulse velocity be? A. If we double the length of the wire, keeping the tension and the mass per unit length a constant. Well, so we keep the tension and the mass per unit length a constant. We double the length of the string. What will happen to the speed or the velocity of the wave on that string? Can you tell me now? Just look at my face and tell me what's the answer. We keep the tension and the mass per unit length a constant. Well, I hope you gave me the answer. The speed of transverse wave on a stretched string depends only on tension and mass per unit length. Is that right? V equal to square root of T over mu. If you keep those two quantities a constant, that means the speed will remain a constant. The speed does not depend on the length. I hope you understand my argument. Alright, V equal to square root of T over mu. The velocity of transverse wave on a wire does not depend on its length. Therefore, if you made the length twice or 3 times or 100 times, it will not affect the speed of waves on that wire, because the speed depends only on the tension and the mass per unit length. Okay, now what's the B part? Double the tension. You double the tension while holding the length and mass per unit length a constant. You keep the value of mu a constant and double the tension. What will be the speed now? Alright, we start by using the same equation. V equal to square root of T over mu. When the tension is doubled, let the new velocity be called V1. Then what will V1 be equal to? V1 then equal to square root of 2T divided by mu, because the tension is doubled. Alright, we can now write this as, isn't it, if you know a little algebra, the numerator can be written as square root 2 times square root T. Or simply square root 2 can be separated. It becomes square root 2 times square root of T over mu. And what is this equal to? Square root T over mu is the original value of the speed, which is 20 meters per second. So that will be square root 2 times the original speed, and that will be square root 2 times 20, and that will be 28.3 meters per second. That means you increase the tension, the speed of propagation on that wire will increase. Is that right? Now you want to tune a guitar wire. You are actually increasing or decreasing the tension. You see that? We will talk about that sometime later again. Now, the third part, you double the mass per unit length while holding the other variables a constant. So this time, you double the mass per unit length, double mu, keeping T a constant. What will happen to the speed? Can you tell me what the answer will be? Just tell me, will the speed increase or decrease? You double the mass per unit length, make the wire thicker. Will the speed increase or decrease? Well, let's find out. Alright, when mu is doubled, let the new speed on that wire be called V2. Then what is V2 equal to? V2 is square root of T over 2 mu mu is double. Now, the same way we did in the previous example, this square root 2 can be separated, but that is going to be on the denominator this time. This belongs to the denominator. So look at the way I wrote it. 1 over square root 2 times square root t over mu. I hope you understand that one. Now, what is this quantity now? Square root t over mu is the original speed, which is 20 meters per second. So how can you write this one now? This is v multiplied by 1 over square root of 2. 1 over square root 2 multiplied by v, and that will be, that v of course belongs to the numerator. That will be 20 meters per second divided by square root 2, that is 14.14 meter per second. That means when you increase the thickness of the string, the speed of waves on that wire decreases. So on a thin wire, the speed will be greater than on a thick wire. Okay, let's move on. Example 6. The cable of a ski lift runs 400 meters up a mountain and has a mass of 80 kilograms. When the cable is struck with a transverse blow at one end, the stretched cable is given a transverse blow. What is the meaning of a transverse blow? If this is a string, a transverse blow is the blow at right angles, creating a pulse. Just like I created the pulse on the spring. So the pulse will go all the way to the other end and get reflected back. Now what happens here? When the cable is struck with a transverse blow at one end, the return pulse is detected 12 seconds later. The energy advanced all the way to the end of the cable and it got reflected, and the energy came back in how long a time? 12 seconds. The time taken for the energy to travel along the length of the wire one way and back is 12 seconds. What is the speed of the wave? What is the tension in the cable? Well, speed can be found very easily. How? We know the distance traveled by the pulse. What is the distance traveled by the pulse? The pulse travels from one end of the cable to the other and back. The length of the cable is 400 meters. So one way it travels 400 meters and back it travels 400 meters. What is the total distance traveled by the wave pulse? It is 800 meters. And what is the time taken for that? It's 12 seconds. You can find the speed of the wave right away. The length of the cable is 400 meters. Its mass is 80 kilograms. The time taken by the pulse to go all the way up and back is 12 seconds. 12 seconds is the time for the pulse to travel the length of the cable and return. And therefore, the speed of the wave along that string is twice the length of the wire. I hope you understand why twice the length of the wire. It has to travel one way and back, divided by delta t. That will be 2 times 400 meters divided by 12 seconds. That is 66.7 meters per second. That is the speed of the wave. Now, we need to now find the tension in the cable. Now, how is that going to be? We know the speed, we know the mass of the cable, we know its length. If you know the mass and the length, what quantity can you obtain from there? you can obtain the mass per unit length. So you can find mu from these two values. We know the speed, therefore we can find the tension. Is that right? Okay, let's do that. Now, mu equal to the mass divided by length. Mu is mass per unit length. That is 80 kilogram is the mass, length is 400 meter. Therefore, the mass per unit length is 0.2 kilogram per meter. And now we have V equal to square root of T over mu. We know the value of V, we just calculated it. V is 66.7 meter per second. We know mu, we just calculated it. Therefore, you can find T. Again, square both sides. V squared equal to T over mu. Therefore, T equal to V squared times mu. And that will be 66.7 squared times 0.2. That will be 890 Newton. You can see most of the problems we solve in here are straightforward problems like this. So please take some time and solve more problems like this. Do your homework. Make sure that you do all the homework problems that I have supplied.